have the bad recording sound-wise, but at least you have something to view if anything, right? You guys also know that you can just look up the subjects that we're talking about and go on to YouTube or anything. And because people have these boards, you know there's a lot of people that teach these lessons. It doesn't necessarily have to be mine. You could even look into other people that are teaching this exact course off of these instructions or this book. Does that make sense? Yes, ma'am. So if I take for Monday, I can do this. I gotta figure out what I can do for you, but I might have just do the review just in case, just instead, because I've already scheduled somebody to drive. That's my issue, is that I forgot about it and I've already scheduled somebody to drive. Then that loses money, and I like money more than you. Okay. Maybe. Okay, awesome. So today we're going to start with 5-4, which 5-4 is just pulling out greatest common factor. Okay. For example, the thing I started with over here is like such. Like such? I apologize. No, it's okay. Here's an example of something that they have in common. What is their GCF? What is a GCF, by the way? Greatest common factor. Now, if you want me to go old school like you've never seen this before, which some of you guys might not want me to do that, but I'll show you. What is 8? Isn't 8 the same thing as 2 times 2 times 2? And then this is x times x. That's called prime factoring, meaning I put everything down into a prime number, right? What's 4? Meaning a prime number is nothing you can break down anymore. Okay? So notice that's exactly what I have. So what do they have in common? They have a 2, another 2, and an x. So what they have in common is 4x. And you should be able to see that instead of having to do this, right? Okay, they have a 4x in common. Well, when I factor something out, because that's what we're doing is pulling out greatest common factors, is I'm saying what's left over? 2x, right, in this case? Minus 1. Now, a lot of people forget, oh, everything's circled here, Mr. Roberts, so there's nothing. But I have everything's always multiplied by 1, correct? So I need to have that placeholder. Would you guys agree that 4x times 2x minus 1 and 4x times 2x are two different things? Because if I distribute this, I just get 8x squared, whereas this gives me 8x squared minus 4x, right? That loses a placeholder if you don't keep them there. Huh? Okay, you guys good with that? Where are my book? Did you take my book, Bridget? Meanie pants? Huh? What pencil did I give you? Well, Bridget, why would I do such a thing? Bridget, you are silly, like a goose. Silly goose. You're so silly. What the hell? 5-3 is what I'm doing. 5-4. Sometimes I just say silly stuff myself. Allison, how are you? Allison, how are you? Look at you, double Allisons. And I got two different people in one shot. Basically, they could both say hello, and I'll be like, hi. You know? No, you guys are mean. Well, because I make people feel comfortable. That is a -3. Do I need to erase that back one? That one kind of looks nasty, doesn't it? Yes. I don't know. Oh, I get that's a Curiel, but okay. No. They come hot? Should I shave it off? No. Just make it touch again. February 1st. Nice. 3 months. Just because I want to get all burly-fied. I'm gonna go cut some trees down. I need to be more of a lumberjack. I really am cutting 3 big trees down this weekend. Did go up in the mountain, maybe 4, because my mama likes to burn wood. She has an indoor fireplace, and it heats her home. So my mom's, how old is my mom? Hold on. 65-ish, 66-ish. So she doesn't get to cut down trees as well.
Thank you.
They're dead trees already, jerk. Okay, ladies and gentlemen, what do these guys have in common? They have a 3C minus 2. Look at you! Some people say gingies don't know anything, but I disagree. Oh, I don't. I've heard stuff. So, like you do. Are you a fake or a real? Yeah, it's fake. That's nice. I'll shut up. I'm digging holes. I'm good at digging holes. Okay, so as Britton just said, they have a 3C minus 2 in common. Britton, that's what I'm pulling out, right? What's left over if I pull 3C minus 2 out of this? We kind of did this with our example on the ones you guys did in 7-1 and 7-2, right? They have a 5C, don't they? What about the second one? What does he have left over? No, that's a 3. Sorry. I didn't know that's what you guys were talking about. That didn't connect. Britton was with me. So it's a 5C. What's left? Minus 3, right? I just pulled out the ECF there. That would be it. Well, then I basically almost get back to where I would have almost been, so it's kind of pointless. That is a fun eraser. Why did you not throw it? That's a good point. Okay, so, hey! I was saying, hey, by the way, jerk. Why you guys always gotta be rude? I am always nice. I didn't throw it at you.
At the table.
And once again, was that you?
Maybe. I'm kidding.
What's your first impression? Was I really that bad of a first impression? Well, what if I want to make it about me? Because everything's about me. Of me or to you? Well, because, yeah, he looks on his damn phone the whole class period. And then I had to call him out on it. Then I feel like a jerk. But then I was the right one. Right. I tell my wife that all the time. She's like, why don't you just give up? Because I'm like, I'm never wrong. In my mind, I don't think you'd have to, yeah, she didn't prove me I was right. But. What do those guys all have in common? Allison, front Allison, because I can't say your last name. Sayless. Siles. Brenton! Allison's answering a question just like they were nice when you answered a question. Yes. Let's start with the numbers. They all have a 2. How about M's? Good. They do have an M squared. How about the N's, as in Nancy's? A lot of Nancy's right there. Okay. Bridget. Is there a Bridget? No. I just lost your name. Oh no. It wasn't Bridget. Help me. No, that's Bridget. Yes. Sorry, wrong person. How about your last name so I can get your first name? Caitlin. Caitlin. If I pull a 2m squared n squared out of 2m to the 4th n squared, what's left over? Yours. And the reason being is because I'm dividing each of these, right? Remember we just talked about that. 2 divided by 2 is 1. M to the 4th divided by m squared is m squared. n squared divided by n squared is 1. Hence why it's just n squared. Okay, let's go over to, Strongo. So, if I pull 2m squared n squared out of 8m cubed n fourth, what's left over? 6, because we're not subtracting it after. So first off, we're going to say 8 divided by 2. 4, because remember, as I would do this, I would distribute it back, right? If I put a 6 here, that would give me a 12, not an 8. So I remember I'm dividing, correct? Okay. And then m cubed divided by m squared. What do I got? Just m. Good. M to the first or m. N to the fourth divided by n squared. Good. Does that make sense, Taylor? Kristen, what if I pull 2m squared n squared out of negative 6m squared n to the fifth? What's left over? Negative 3n cubed. Yeah. Do I need to go over that for people, or are we okay? Pretty good. Okay. Love you all. Not really. Sometimes. I don't care. Really, right now, it's great. You guys know what makes me so excited this year about teaching you guys? Is that I don't ever have to grade read this stuff. Now, you guys might hate it, but it is like the highlight of my year. On a 1 to 10 scale, it's like at a 21 of how important that is. Because I hate grading retakes. Why do I hate grading retakes? Because that's a lot more tests to grade. Yeah. Yeah, Bridget. Just because I forgot your name for 30 seconds and right, Madison, Dunn, Madison Beach Coco or something like that. Nesper, yes. Madison, what is those for? This is called, by the way, factor by grouping. I should tell you what it is. You ready to rock and roll now? No? No? They just fall on your thing. Ready to rock? What does the front guys have in common? A 3 what? X. They have an X as well, right? So if I pull out that 3x, 6 divided by 3 is 2, and then x squared divided by x is x, right? And then what's left over after I pull the 3x out of 9x? Okay. Declan, what does the next guys have in common? What kind of a 5? I'm going to pull out a negative 5, okay? Declan, if I pull a negative 5 from a negative 10x, what would be left over? Negative 15 divided by negative 5. Ooh, do you guys see how these are the same? So isn't that one that I just did with Britain? Right? Britain did one of these. What do those guys share? They share 2x plus 3, right? And Adam, what's left over? There we go. Okay, that's 5-4. 5-5 is factoring in general. I have a specific way that I like to factor, but just because I do it my way, does that mean it's the only way to factor? No, there's many different ways. I was taught to guess and check. It sucks. Okay, let me explain how I had to do something by guess and check. For example, oh the hell, come on. Oh, hey! You gonna drive? Are you the younger or older?
I'm older.
I get confused. I actually came to find you yesterday. I found your sister, and I almost got her to drive. And she's like, "Why don't you ask me?"
You don't want to drive.
Why? why is she not driving? I know, so what, you drive to the grocery store, she drives back home.
I'll come back and talk to you.
But I would love you to drive this week if you want to come after school today, huh? Oh. I don't like this one. I'm erasing it. Yes, it should be. Our life is sad. I know. Oh, nope, I don't want to do that one. Just don't write anything yet. I'm thinking in my head. I'm thinking. I have a brain right now. It's really hard. Got it. Nope, that is not it. 28. Make it a 28x. There we go. Okay. This is legit. That is what it is. Okay. Now, this is a trinomial, and we're going to go back to a binomial, the two binomials, kind of like this. Okay. We're making something come back into factored form. Okay. Factoring is one of the biggest skills to have in mathematics. However far you're going to go from here on out, you will factor the rest of your mathematical adventure. Okay? Does that make sense? I factored up into advanced calculus, which was like Calc 5. Does that make sense? So like it's nothing, it's always however far you're going to go, factoring is a key. All right. So what I was taught is just jump right into hippo butts. Doesn't that look like a hippo butt, like Moto, like, right? You know what I mean? It'd be like those hippos, like a large. You guys ever seen that movie? Huh? Madagascar, I don't know which one, but yeah. Okay, so I was taught guess and check. My guess and check method was, how do you get 3x squared? I need a 3x and an x. How do I get to 20? Well, I got lots of options, don't I? I have negative 20. I have 1 and 20, 2 and 10, 4 and 5. Well, those are the options I can put here, right? But if you'll recall, I have to then make sure it adds to be what? 28. So what number can get me close to 28? Well, if I times 3 by 1, that means 1 would have to be times by 20. That doesn't get me there. Like you go 3 times 10, that's 30. And then a 2, that's a possibility, huh? Okay? Or 3 times 5 is 15, 3 times 4 is 12, so they're really not going to get me there either, right? So the best one is this guy. But you see how it's like so uncertain? Right? Meaning I'm going to put a plus 10 here and a minus 2. Why do I have 1 negative and 1 positive? Because I have to get to multiplying to be a negative 20, don't I? So kind of, didn't I have to kind of foil in my head as well? 30 minus 2. Did everybody see that? So I personally just didn't like that method. I got pretty good at it because that's how I was taught. But I've been taught a different method, and that's completely how I go about it now. Okay, and I'm going to show you guys that method. And a lot of teachers do show this, and like I said, if your teacher didn't show my method, is it still okay? And you can try whatever method they taught you. I'm okay with it, as long as I can follow it. Okay? So here's what I'm going to do. What I do is I take the front number to the back number. I call that my rainbow. Skittles are popping out left and right. And I taste it. Okay? So this is negative 60. What are my factors of 60? 1 and 60. 2 and 30. 3 and 20, as you brought up. Now I'm going to show you a trick. I'm going to show you every factor. Can 4 go into 60? 4 and 15. Can 5 go into 60? 5 and 12. Can 6 go into 60? Now notice I'm hitting every single one. Does every factor always keep lining up with number after number? Can 7 go? Can 8 go? Can 9 go? See how 10's on the other side? That's my next number that I went through. Did you see I went through all numbers 1 through 10 until it wraps around? That shows that I'm using every factor. And you want to make sure you write down every factor, because the time that you don't, that's the time you're going to need that factor pair. Does that make sense what I'm saying? So make sure you write down all the factors. Now, negative 60. How do I get to a negative 60? One has to be a positive and one has to be a negative, right? Now, if you'll notice, though, we're looking at factors of 60 that subtract to be 28. Which pair subtracts to be 28? 2 and 30, right? Okay, what if this was a plus sign, though? Do I subtract or do I add? Add, because they have to have the same sign, don't they? You guys agree with that? Okay, so they would have to have the same sign. But in this case, I get to go ahead and have different signs. Now I need to ask myself, who gets the positive and who gets the negative? It does matter. The 2 gets the negative. Can you explain why to me? 30 minus 2 is 28. If I had it the other way, if I had positive 2 and a negative 30, what would that equal? Negative 28. Then I changed the function, didn't I? The expression, not necessarily function right here, but I did change the expression. Okay? So I want to keep it the same, and the reason how I can do so is just making it different. Now this is exactly the same thing as we just looked at right here. We did factor by grouping, didn't we? We looked at the front 2 and we look at the back 2. What does the front 2 have in common? They do have an x. Can you tell me what's left over, Alex? Good. Okay. Tyler? Taylor? Tyler. Taylor, it was Taylor, sorry. Taylor, what do these guys have in common? 10. So I'm going to pull out a positive 10. What's left over? 3x minus 2. Once again, we're looking for those to be the same. Because at that stage, I can factor out who? 3x minus 2, and left over is x plus 10. How many of your previous teachers have showed something of this sort? Anybody not seen this kind of a style? Kristen, no? You didn't go to school here last year. Where did you go to school? Colorado. How did they teach you to factor?
They just kind of do box, you know.
No. You want to? Can you show me on this? Do you remember?
Maybe. Yeah.
Okay. If you guys don't want to listen, don't listen. But be respectful. I'm going to write what was up here so you can reread through it.
We had to draw like a box and then like an X, and then like up here would be the first number 3 X squared into the last number negative 20, and then I forget which one goes on top.
Oh, so you did the number draws. I've seen that before. I don't know how to do it, but
yeah. And then we had to find what number. Oh yeah, adds to 28.
But multiply to be negative.
To negative
So
20, and then just
yeah.
it's kind of the same.
It's kind of a lot of the same way that I do it, but I think actually you're supposed to write negative 60.
Yeah.
So this is supposed to be things that add to be 28, but multiply to be negative 60. Or either way. Okay, or 20, yes. Okay, so either way though, it's working. And so then they figure it out. They don't divide or anything, they just figure it out, right? Kind of like just how I do. So it's very similar, but then it goes back to an area model where, once again, that was me using the 30x and this is being the negative 2x, right? And some people like that because then they can say, what does this row have in common? A negative 2. What does this row have in common? A 3x. What does this column have in common? An x. What does 30 and negative 20 have in common? A 10. So a lot of it's a similar thing. He just did it in an area model, just like we did in the past. Okay, which is very similar because you still had to figure out what things times to be 60 but get to be 30 or 28, right? Kind of the same thing I'm doing. Is everybody with me on that? That's what exactly he just did. Okay? So, not too bad. I just want to show that there's different ways. Anybody else do something else? Did anybody ever learn guess and check like I did? You did? I'm sorry. It sucked, didn't it? And then you get good at it. I got fast at it. I'm not fast anymore because I haven't used it for so long. I always use this method now. I did too. But you never want to see a 24. Those things are beastly. Because 1, 2, 3, 4, 6, 8, 12. A lot of things go into that sucker. Ugh, 32s. Oh no. They're like ready. Now, what even if I had this guy to be a, let's say he's a 12. Instead of this one, how am I guessing check? Remember how I did really easy 3x and x? What if it's a 12? How many options could be there? I could have 1 and 12, 2 and 6, right? 3 and 4. Then I got to find out which of those ones match up with the factors of this one. It became a hell process. And so I love the method that I showed because it works every single time, if it is something factorable. We all agree that not everything's factorable. Okay. But on our test, they will be. Because that's what I'm looking for is something factor. Now, I can't remember if we get into quadratics and things, like the quadratic formula, I think we have to be, right? There's going to be cases that they don't. All right. No, not today. I think we do get into it, though. Oh, fricker, fracker, snacker, snackers. Really? Biscuits and gravy. That's what my daughter really enjoys, is some biscuits and gravy. Anybody else like some biscuits and gravy? It's not my favorite. We had it on Sunday because it was my daughter's birthday, so she gets what she wants. What a rotten brat. She is the big double digit. She hit 10. I met a family that double digits was bigger than, because you can only change digits really once, most of the time once. Going from single to double, not many people reach double digits. So it should be a pretty big milestone. Anyway, this one's a little different because I got p squared and some q squared and all that fun stuff. And you're like, holy snipers. Right? But I'm going to treat it just like I ignore this q right here and this q right here for it. Redhead stepchild. Okay? So, my siblings were redhead stepchildren. They got ignored. So. Anyway, I'm going to go 1 times 45. What's the factors of 45? Here we go. 1 and 45. Can 2 go? 3 go? 3 and 15. Can 4 go? 5 go? 6 go? 7? 8? 9? It's already wrapped around. See how I went through every number until it wrapped around? That makes sure that I get every factor, okay? All right, this time it's a positive 45, so am I going to add or subtract? Add, and they have to be the same sign. They're either going to be both positive or both negative. In this case, is it both positive or both negative? Both negative because he is a negative 14. Right? Okay. So I need 5 and 9. Agree? So I have p squared minus 5pq minus 9pq plus 45q squared. Okay. You sure? Okay. What do these guys have in common, ladies and gentlemen? A p. Left over is p minus 5q. Abby, what do these guys have in common? They do have a 9q, but I'm going to tell you guys, anytime on your third term or your first term, if they're negative, pull out a negative for me. So instead of just a 9q, I'm going to pull out a negative 9q. And the reason why, guys, is What's negative 9 divided by negative 9 cubed? That would just be a p. Once again, if I just pulled out 9, he would be a p and he would be a negative p. Are they the same? And I want them to be the same, correct? Does that make sense? And then notice 45 divided by negative 9 is negative 5q as well. So what do they have in common? P minus 5q. What's left over? P minus 9q. Okay. How are we doing? Are you still uncomfortable? Is this stuff that you guys kind of sweeping some cobwebs away, though? We've done kind of factoring in the past somehow, some way. And you're more than welcome to do your method. Does this make sense, though? It's very similar, it's just a different style of writing it. Okay? How about something like this? Oh, you scumbag, you're back. Who was that?
I don't even know who it is.
That's it. This is called a difference of squares. Because 16 is some number perfectly squared, right? What is 16? What number squared gives me 4? What number squared gives me x squared? X. So 4x is, if I square that, I'd get 16x squared, correct? How about 9? What's the number? 3. You guys see how this is called a difference of squares? On your homework, some of you guys multiply what they call conjugate, and they would come into difference of squares. Did you guys notice that in your homework? Okay, difference of squares. I hope you actually see them as a pattern, because they actually go into something very simple every time. But I'm going to show you that you can still do it without it. What's the number in the middle even though he's not there? How many x's do I have? I have 0 x's, don't I? I have x squared. I have 16x squared, but I have 0 x's. Do you guys agree with that? Did I change the value of my expression by writing that? No. Okay, so here we go. What's 16 times negative 9? Okay. What number, for me to get to a 0, don't they have to be the exact same? So it has to be 12. I'm not going to go through the whole list because I know there's only one solution to get me to be 0. They have to be the same number, so basically think of the square root of that number, right? Does that make sense to everybody? You see how I get 12 there? Okay, so I'm going to rewrite again. Hello again, lady. Would you like to tell me what they have in common? 4 and a... Good. What's left over if I pull out a 4x?
4x plus 3.
Good. Joseph, what do these guys have in common? What kind of a 3 am I going to pull out, though? Because, once again, our third term is negative, right? Could I have flip-flopped that? Does it matter whether I go 12x minus 12 or negative 12 plus 12x? Does it matter? No. And sometimes I usually like to just put my positive term here, so I don't have to worry about pulling out negative. But as Joseph said, there's a negative 3, and tell me what's left over, Joseph. Close. What's negative 12 divided by negative 3? So you forgot your 4, right? Sorry, she's a plus. So notice this comes into 4x minus 3 and 4x plus 3. Do you guys see how they're the same numbers, just assigned into different? These are called conjugate pairs. Would you like me to show you? The only thing that would be different is that this would be 4x plus 3, and this would be 4x minus 3. It just switches these two out. Does that answer your question? Notice, guys, difference of squares will always be into conjugate pairs. What was the square root of 16x squared? 4x was the square root of 9. That's where they come from, is their perfect squares. So really quickly, I could do 25x squared minus 121. What did that do without even have to factor? 5x plus 11, and that would be it. Difference of squares go into conjugate pairs. Kind of does. Okay? Any questions there? I got one more example for you, and then actually we have work time. Okay? This one's a little bit intriguing. Okay? Let's say I have this. Don't write that yet because I'm not sure. Give me a number, a reasonable number. 6. I'm not going to do it. How about a 9? And then I want us to factor this into 2 binomials. Okay? But can you guys see that it's very similar to something like this? Notice I have something squared plus 28x or something x minus constant. Notice, look right here really quick. I have 2 times something squared minus 3 times that something plus our constant. You guys see that? Okay. Now I got 2 options. I'm going to show you option A, which I probably wouldn't do because I think it's very easy. But you could. Notice, what's x plus 5 squared? I know that to be x squared plus 10x plus 25 because I know how to do that really quickly. If I times that by 2, I get 2x squared plus 20x plus 50. Does everybody see how I did that? Okay, and then this guy becomes negative 3x minus 15 minus 9. You guys see what I did? I just expanded everything. And that simplifies to be 2x squared plus 17x, that's 35 minus 9, so 35 minus 9, 35 minus 9 is 27, 26. Okay. Is everybody there with me? Did I do that right, by the way? Let me just quickly check. Okay. And then I can just factor him like I was just been showing you, correct? Can we do that really quick? Yeah. Thank you. Appreciate that. Okay, plus 26. Okay, so I go 2 times 26, which is 52. A positive 52, and I get 1 and 52. Yep, 2. Thank you. 2 and 26. Can 3 go? Nope. Can 4 go? 4 and 13. Ah, there's my pair that gets 17 from. Did everybody see what I did there? Okay. But I'm going to show you a faster method after I'm done here. Oh, 13. I have to check that. Is that better? Okay. What do the front 2 have in common? Chrisette, can you tell me what the front 2 have in common? Good. What's left over? Oh, I already pulled out the 2. So those are gone. What's x squared divided by x? Good. And if I pull 2x out of 4x, I have a 2 left over. Good job. Okay. Got Carter, what do you guys have in common back there? What's left over? Left over is x plus 2 and the 2x plus 13. Okay. Now, I'm going to take this exact same thing at the very beginning and do it a different way, and I'll end up with this same result. You guys believe me? Well, you better, because it's going to come out. Ready? Here we go. So what did I have? I had 2x plus 5 squared, right? Minus 3x plus 5 minus 9. Okay. hopefully, you might not see it right now, but I'm going to call x plus 5 u. Now, you might be all like, Mr. Roberts, why the heck is what's this? I'll use substitution, or w, or any variable substitution that you want to use. But if I replace x plus 5 with a u, don't I get 2u squared? You guys agree with that? Minus 3u minus 9. You guys see how I did that? Just by substituting what I said u could equal. Let's go ahead and factor this guy. Okay? Because that looks like something I could factor, correct? So that's the factors of negative 18 that get me to be 3. 1 and 18? Nope, that doesn't get me there. How about 2 and 9? Does that subtract give me a 3? How about 3 and 6? That does, huh? So I can rewrite this to be, okay, that's 2u squared minus 6u plus 3u minus 9. Is that hard? Are we okay? That's something we could all still do, right? What do those front guys have in common? 2u left with a u minus 3. What does the next guys have in common? A 3. What's left over? U minus 3. So what's my factorization? U minus 3 times plus 3. But did I start out with u's? Who did I start out with? X plus 5. So what am I going to do with those u's again? I'm not going to distribute. I'm going to substitute them back in. Okay? So instead of u, that's x plus 5 minus 3. What does that simplify to be? Is that one of them? 2 times x plus 5 plus 3. So that's 2x plus 10 plus 3, which is 2x plus. Is that what it was? You choose which method. Okay? But the cool thing about math is you can see different things and just substitute, and it still follows the same rules because it's in that similar formula, right? And in the end, as long as I substitute it back, is it any different? No. Okay? Does that make sense, everybody? Are we pretty okay? And we already gave you the homework, right? Okay? Both are on page 442, correct?
Yeah.
Can somebody hear you just so I have it on here if somebody's gone? 65 through 79 and 81 through 97. So basically 65 through 97 odd. Right? You guys got 15 minutes. Please use your time wisely for me. I'd really appreciate it. Okay? All right, guys. Thank you.